First, I'm gonna introduce myself. My name is Matan Cohen. Okay, I joined Wiz 4 years ago. I looked really good back then, and I grew up a lot since then. And what I do today in the editors is working on a framework, internal library, which is called Editor Core. And because it has core in the name, you know it's important. And what it does, basically, we have in Wix different editors. Okay, we have editor which is catered more for agencies, an editor which is more like DIY user, and we have a mobile editor for building mobile apps and widgets and many, many more. So this library, this platform is used to enable us to reuse code between the different products. So we have large code bases, and this library in the future will help us to share code between all of them. So this is not a Wix meetup, it's TypeScript meetup. So why I mention it? Because I write a lot of types, okay? Because it's a library which is used across many editors, I write a lot of types and complex types. Okay, some of them are pretty easy, like unknown object or recursive read-only, which is a little bit more complicated, but some of them are a nightmare, okay? And this is how I look when I try to write them, okay? It's pretty difficult, and in the beginning of the project, I had really hard time to writing these complex types. I changed something and something break. I tried to rewrite something, and it didn't work at all. But then I found something, okay? I found type testing. And this is an auto-generated image that I did, not the hat. This is, I just put it here. But when I found type testing, things really became much easier. And this is what I want to share with you today. So you can also put your party hat on when you're trying to write complex types. So I'll take a sip and we'll continue. So what we're going to do today is help a dear friend of mine. I think some of you from Israel know her. Her name is Kochava, and she is the star, pun intended, of the show Kuparashit. And she has a pretty special need. She wants to build an app which is called Revenge for You. This app, what it does is manages revenge. So if I want to create revenge, to delete a revenge, and maybe we'll add some AI, so because every lecture needs to have AI. So this is what we're going to do today, and we're going to help her do it with types. So let's go over the types we're going to have in this app. So the first type we have is a simple type, an object, revenge. First thing we have is a field of reason. Why we're going to do this revenge? Is it because someone annoyed us, because he did something to us? And we have a revenge target. What's a revenge target? So it's basically another object with a name, the name of who we're gonna execute the revenge on, and is job title. And the job title is a union of different jobs. We have a branch manager, a senior general employee, cashier, butcher, and I also added an annoying customer because it's a full-time job to be an annoying customer. So we have a revenge, but we also want to have a revenge plan. So the types we have for a revenge plan is divided by severity. Okay, the first type is the revenge plan low, which has the target that we see before, the severity low, the actions that we need to do in order to execute the revenge. For example, pull down his pants, one action we can do. And the forgiveness probability, okay? How likely from 0 to 1 for him to forgive us. Then we have the revenge plan medium. Again, the target, severity, and action repeat themselves, but we have something a little bit different, okay? How embarrassment our target's gonna have when we're gonna execute this revenge. After that, this is more special use cases. We have revenge plan high, okay? We again have the target, the severity changed to high, the actions stay the same, but how many times it's going to take our target in days to recover. Okay, it's going to be pretty significant revenge. And how long for him to recover from revenge? And for special cases, we have revenge plan extreme. Okay, this is when we go all the way in order to revenge them. We have the target, severity extreme, the actions we're going to do, but also we need to take into consideration, because it's such an extreme revenge, the collateral damage we're going to have from doing this revenge, and if there are legal consequences, yes or no. Okay? So what we're going to do with our types. So let's see. We want to create a function which is called generate revenge plan, and it has an input of revenge, that the type that we saw before with the with the target, and we want to to generate a revenge plan. But we have some constraints that we want to apply to the revenge plan. Okay, we don't want to generate any revenge plan. We have some requirements. The first requirement is that for annoying customer, we want always to generate a revenge plan extreme. He deserves it, okay? We must create a revenge plan extreme for him and nothing less. For the branch manager, we want to generate a revenge plan high, okay? We hate her, but not as much as we hate the annoying customer. The third requirement is for senior general employee. We want to generate revenge plan low. We want to prank them. We don't want to do something so extreme like for the bench manager on the annoying customer. And lastly, if none of these criteria match, we want to generate or revenge plan medium or revenge plan low. Okay, so we have all the requirements that we want for our type. So usually we'll just start coding, okay? But in this case, I'm going to introduce to you type testing using vtest. There are other ways to test it, but today we're going to explore a little bit how it's done via vtest. They have great framework for type testing that you can use. So if you're familiar with vtest or any other testing framework like Jest or Mocha or whatever, it has a function of testing like eat or describe, but in vtest type testing it has special function which is called expect type of. Okay, this is from the documentation of vtest, and we can read it. So expect type of is similar to just expect, which like in Jest you do expect this variable to be 4, okay? But it has type awareness, okay? And it gives you access to type matchers. So if we look at the example down below, let's take a look at the first one. So we expect the type of foo, which is a variable and object, to have exactly the type of A1, okay? Not a number in this case, but exactly a 1. Or we can check that the property A is a number. Okay, so it has a type awareness. And we also can check the parameters and not, and to be any. It has a lot of matchers that can help you write your type tests. The most important function that I usually use is the equal type of. So I want to explore that a little further. That function basically is used again with the expect type of. It's using the internals of TypeScript in order to match identity. So if you played enough with TypeScript to know that two things are identical, it's not that easy. Okay, with the object that extend each other and all that kind of stuff, it's not that simple, but they're using the internals of TypeScript in order to do it. So usually it's better than us reading us ourselves. And it has two ways of doing it. The first way is using the type argument, okay? So if we read it, we expect type of object of A1 to equal type of generic param, okay? We passed directly the generic params we want to test on. Okay, so this is one way to use it. Another way is let the type system infer the type, and then just call it the argument, which will be inferred by this function. So it's two ways. So if you have a type, you can just directly put it as a generic param. And if you have the object itself, the function or whatever, you can pass it as a param and it will be inferred automatically. So I hope that was clear. And now we're going to write our first test. So this is for our annoying customer. So when writing tests, we can actually write them the same as we write regular tests. Okay? In the end, they will not, Vitess has something that does execute them to show you nice output on the screen, but they're not really executed. They're just running TypeScript on them, see if they pass or not. So our first test, exactly like our requirements, we're doing basically kind of a TDD, but for our types, is should we get the revenge plan extreme for annoying customers. So we want to make sure when we call generate revenge plan, in this case, there is really no need to explain why we want to generate revenge plan for this annoying customer. We want to the output of that function to equal the type of revenge plan extreme. Okay? So after we write this, we will get an error. Okay? Because the type of revenge plan, the function we saw before, is revenge plan, which is the union of all the revenges and not the revenge plan extreme. So we see, just rewrote it, that we have an error. But we will continue before we change the type to write all the tests. So our next test is should get revenge plan high for our branch manager, okay? So why? Because his sticker knows in everyone's business. And again, we have the same error. We'll continue. So for the senior general employee, we want to get the revenge plan low. And because he loves Shira too much, and we want to prank them or do something like that. So this is a revenge plan low. And lastly, we should get back revenge plan medium or revenge plan low for example, a butcher. It could be any other type that does not answer the requirements that we saw before. In this example, we tested butcher, and we should get back a union of revenge plan medium or revenge plan low. Okay, so before we started writing on type, we write all the requirements that we know that Kohava told us we want to have in this type. So let's run it. Everything fails, okay? Great, so it doesn't work. And now we can start writing our test and be sure in the end that it's working. So we try to first pass the first test. So we did a little bit of changing, okay? So instead of getting a revenge type directly, we took it as a type param, okay? Why? Because we want to ask some question about that type. Just getting revenge plan will not let us do it. So we took a type param, t extend revenge. We want it to be a subtype of revenge, at least revenge, and then we can generate the result. So let's see how we're going to build that type. Okay, so the first use case, we should get revenge plan extreme if it's annoying customer. So what we did is to check. We already know it's a subtype of revenge, but we want to be more explicit. We want to make sure that the title, the job title of our target is an annoying customer. Okay, this is a ternary operator. I hope you are familiar with it. And it just means that if the revenge we got is the target has a job title of annoying customer, then we return revenge plan extreme. And if not, for now, we return never. We know that we don't know what to do for now in the case it doesn't work. Okay, great. So we run the test again, order and watch, and we see it immediately, which Vitess also support watch mode for type testing, which is really nice. And great, okay, we passed our first test. Let's continue to change our type. So now we did a little bit more changing, but pretty trivial, okay? We didn't change too much. We added more branches to our conditional types. So the first thing we added, so if his title is not an annoying customer, we check if the job title is a branch manager, okay? Exactly like our test said. And if so, we return the revenge plan I. And if not, we check again if the title is a senior general employee. And if yes, we return revenge plan low, and we fall back to never. So we run the test again. Boom, 2 more tests, okay? We are making progress, we're almost there. And we have one last test to pass, and I think most of you know what should be the last conditional there. So if none of the requirements have, we want to default to revenge plan medium or revenge plan low. And running again, and we passed our all tests, okay? So what we did basically, this is kind of a trivial example, okay? But in reality, it helped me to build a very complex type with knowing the requirements I know exactly beforehand. For example, I wanted to extract from some array some type, and I knew all of it beforehand. I wrote the test before, then the process of creating this type was much easier. Exactly like we did here. Basically, TDD for types. And VTest let you do it pretty easily. So, repeating it again, type testing can help you to create complex type and save you time. I really want to make sure this line came true. Okay, and it's also, like all testing, but it can help you enforce business rules, okay? We have like 4 business rules that we wanted to enforce that Kohava told us, and they are enforced by type and by test. So if someone comes in the future and try to change the type, this test will fail. And in my library, when it fails, the build fails, okay? So you can't just change the type and fail a test. You can always force merge, yeah, but we don't do that. And you will break the build, and you will need to explain why you need to change and if you want to change the test or not. Okay, great. I hope this was really nice for you. And we have another way to test our types. Okay, so this was like the positive test, but let's try to do another thing. Okay, so we have a function, okay, which is called hire Kohava. Okay, what we want to do is basically, Kohava is a pro, okay? She knows how to execute a revenge. And we have a special place in our application when we can hire her, okay? But she doesn't deal with little pranks. She want to do only revenge that are higher than low or medium, okay? And if we look and read this type, so basically the revenge plan is a type which uses the exclude built-in type. What this type do? It's taking the revenge plan, which is a union of all the types, okay, and removes from it what we have in the second type param, the revenge plan low and revenge plan medium. So basically, we want to say, no matter how, if you have mega extreme revenge in the future, we will handle it. But if you have, but I will never enter revenge plan low or revenge plan medium. This is the business rule that we have when we try to hire Kohava. And we want to also enforce it by test. Okay, so we wrote another test, but this time it looks a little bit different. Okay, so let's see what's going on here. So we created a revenge plan low, okay, for Anatoly. And we said we want to put a frog in his pocket, okay? Maybe it's more than low, I don't know, but this is what I think it's low. And it forgives us in 50%. And we used the directive, it's called these comments here called the type directive, which say TS expect error, okay? And then we explain why we expect error. So what is this directive? Basically, it's let you specify that an error will occur in the next line of the file, okay? If you're familiar with tsignore, it's a better version of that directive. So if we use this, if we remove the directive, we'll get an error, okay? Because we are trying to pass revenge plan low to a function that doesn't accept it. But if we put it back on, everything works, okay? So what does it mean? What our type try to check? Oh, sorry, passed one too much. So our test try to check that no one will change the type to accept revenge plan low in the future, like we see here, okay? If the type look like this, if someone will change it, then we'll have an error when we called iokohava, and then the build will not pass. So let's see that right here. Someone changed the type, okay? Change it to revenge plan, which said you can hire Kohava for any revenge. And what happened? We got an error on our directive, okay? So in this case, we are not checking for positive type checking, but we want to make sure that error will be thrown, okay, by the type system. In this case, we can use the TS expect error directive, and a lot of tests are actually written like that to make sure that the types are working as we planned and don't accept input or throw errors when they don't need to. So this is a very useful technique to check our types. Great. So use TS accept error directive when you want to make sure that an error will occur, okay? Awesome. So this is our first version of Revenge for You. It's ready and we shipped it, okay? A lot of people created Revenge, enjoyed the app, enjoyed our AI, but something happened, okay? We have Shuni here. She called our call center and told us, guys, the apps keep crashing. And we said, oh, can't be. We tested everything. We looked at the code and we found something pretty odd. We find this kind of code. Someone did some refactoring, removed some constraints on the type, and basically made this function to be get revenge of anything, okay? What we see here, we put a type param with no constraint at all, which basically mean give me everything, I will create revenge for nothing, okay? For anything, sorry. You can put anything you want. We were pretty upset because we test our system so well, but we forgot to test this type and someone changed it, and we have a lot of bugs in our app. So some cases, which I actually had this week when I looked back in the library and I noticed that something doesn't work. And I actually caught a type bug that I missed when like I had two parameters and they were not supposed to be interchangeable, and they were. So what I did is I just went and created a type test, so this bug will not happen again. So this is what I'm gonna do now. This is a pretty trivial example, but you can imagine, like you catch bugs in real code, real running time code, you can add tests after you catch bug in your type systems. So this is exactly what I'm gonna do. We're gonna use the TS expect error directive, and basically we're gonna give it garbage data, and we want it to throw an error, okay? We don't want to accept anything. And then we fix the type, we just change it to revenge. We don't know why someone did this complex type with generic, we just wanna get revenge and add it. And the error is gone, and we are safe if someone's trying to do some shenanigans in the future with our types. So this is another case when adding type tests can really help you. Okay, so if you find a bug in your types logic, you can add a test to prevent it in the future, which I actually did this week and had a chance to add it to the lecture, which is really nice. Okay, but Bosga, what if I don't want to use VTest? If you don't want to use VTest, you don't have to, okay? I recommend using VTest because it's pretty easy, someone writing it for you, but you can write types your own in order to check your types. So let's see what I'm talking about. We're going to use two simple types. Of course, the types is what VTest gives us, it's way more complex than this, but these two simple types can help us to write type tests our own. Because in the end, you need to remember it's not really running, okay? Just running TypeScript. So we can just recreate these two types, and I'll explain what they want to do. So the first type is basically said, if t extends true, return t. What does it mean? In the end, it's want to say if t is subtype of true, which basically want to check if something is truthy. Okay, for example, we can see if this array, okay, is array of numbers is really an array, which is truth. Okay, so this is one function that can help us. And the more complex type that we see here, I would get into the details why it's using an array and checking true or false twice. But if someone can explain later, it's because of unions. But basically, what this want to do is check if two types are strictly equal. Okay. So if we look at the example, we want to see if an object which has a field of A and value of 1 and field of A, B they are strictly equal, and you can see by yourself that they are not. And they just, by comparing them, we can return here true or false. So if we combine these two, we can create the same test we created before. So if we look at this example of a test we did before, we should get revenge plan extreme for an annoying customer. So here, unfortunately, because it's not like a VTest, we need to specify a type of revenge plan, okay? Because no one is gonna infer that type for us. And as the second parameter is what we wanna check against, okay? So the first parameter is the revenge plan, and we wanna make sure is the revenge plan extreme. This expression will return true only if they match, okay? And then if they match, the types must expression return true, and expect will not throw an error. If they didn't match, then expect will get false and will throw an error. Okay, so basically we build the same test that we saw before ourselves, which is pretty nice. You don't have to bring another library. You can just write your own test. It's a little bit less convenient to work with, but it's working if you want to. Okay, so let's sum up what we learned about type testing and see if you can answer the question. So if you build a complex types and you have a hard time to figure out if it's working, what do you need to use? Yeah, type testing, very good. Okay, so you need to use type testing. If you're planning to build a complex type, what do you need to use? Yeah, type testing, exactly. And if you want to make sure that no one breaks the business rules and logic of your types, you need to use, what a great crowd, type testing, okay? And if you found a bug in your types logic, yeah, and if you love TDD and miss it for types, you can use, yes, great. Thank you.